Hello, everyone, and thanks for joining us today, and welcome to the latest DZone webinar. My name is Jason Cockrum, and I'm the Community Engagement Manager here at DZone. We're glad you're here today. We've got a really relevant and an exciting topic for you, and so we're happy that you've joined us. If you are new to DZone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and really anyone who's passionate about software development. We've got things like ref cards and trend reports and thousands of articles written and published by the experts in our community. And all this makes us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one today, and you can find them all on our website at dzone.com/events. We've got things like fireside chats, virtual roundtables, webinars, and who knows, you might even see us in person at an event near you. So be sure to check out dzone.com/events for all that information. Today's webinar is about something that's pretty important and relevant to quite a few of us, and that is CI/CD. A lot of us understand the significant benefits that can be had from adopting CI/CD practices, and the even greater benefits of automating those practices. But as always is the case, these benefits don't come without risk. So introducing automation into CI/CD can significantly increase our efficiency, but it also introduced some additional attack vectors for bad actors and other things like that, right? So today we're going to talk about some of the common attack scenarios for CI/CD pipelines and some best practices for securing those pipelines. Joining me today is Omer Gill. He's a senior security research manager at Palo Alto Networks for the Prisma Cloud, and he has over 15 years of experience in application and cloud security. And most famously, he discovered the web cache deception attack vector in 2017. He's also co-authored the Top 10 CI/CD Security Risks project and helped create the CI/CD GOAT project. So clearly, he knows CI/CD. Before joining Palo Alto, he founded and led the research division at Cider Security. And since Cider was purchased by Palo Alto, he leads the AppSec research for the Prisma Cloud platform at Palo Alto Networks. So here at DZone, we're all about community, and so we encourage you to get involved and to get engaged in our conversation. On the right side of the screen, there's a box where you can chat with other attendees about your own CI/CD pipeline experiences and discuss what's being talked about, and there's also a box where you can submit some questions. And we'll do our best to answer as many of them as we can towards the end. So at this point, I'm going to stop talking and turn it over to Omer. Omer, take it away, my friend.
Thanks. So hello, everyone. My name is Omer Gill, and welcome to my talk, where we will see how attackers abuse CI/CD environments to reach production. And just before we get to the point, let's start with a quick intro. So most of you probably work with CI/CD pipelines on a daily basis. Nearly any company that develops software has pipelines used to build, test, and deploy their code. And usage of CI/CD is becoming more and more common as the years go by. The best testament to that is this amazing statistic that you can see now on the screen, where we see the monthly pipeline executions in Jenkins, which is still the most widely used build systems in the build system in the world. We can see that today there are 58 million pipeline execution in Jenkins instances each month, and it nearly doubles itself every 2 years. It's kind of the Moore's law of build systems, and attackers are aware of these statistics. So today, you will see how these attackers are using your pipelines to reach production. So let me introduce myself quickly. My name is Omer Gill. My background is built of multiple security disciplines, both defensive and offensive, like hacking to web applications and cloud environments. Until a few months ago, I led the research at Cider Security, which was focused on securing software delivery pipelines. It was acquired by Palo Alto Networks, as just mentioned. And besides our product that we are highly focused on, we try to work with the InfoSec and dev communities and contribute in any way we can. One example for that is the OWASP Top 10 CI/CD Security Risks Initiative. We saw that defenders lack knowledge and methodologies of how to protect their CI/CD ecosystem and understand what risks they should protect against. And these risks aim to assist us all in focusing on threats in this domain. This initiative is the result of extensive research with a strong support from the community, and I highly recommend you reading it. And another project that we are very proud of is CI/CD GOAT. It's a deliberately vulnerable CI/CD environment with 11 different challenges based on the top 10 risks. Allow everyone to practice on hacking to CI/CD environment and also to defend them. So I recommend you all to look out for it, download it, give it a try, maybe even contribute your own attack scenarios. It's pretty cool. So after all that, let's begin. So looking back at past security incidents, we've witnessed many high-impact attacks against the cloud environment of the biggest firms in the world. For example, Uber with 57 million users exposed through a public S3 bucket in 2016, Tesla that had crypto miners running in their servers, or Capital One that got a small fine of $80 million after they suffered from a cloud data breach. And these breaches happen for a reason, with the rise of DevOps and cloud computing, where everything is automated and deployed fast and easy. A new attack surface was introduced, which is reaching the organization's crown jewels, the production systems. And some of the most common attack vectors against these production environments are breaching the perimeter, like exploiting known vulnerability in a public-facing, an internet-facing server, or a SQL injection attack against some app. It could be abusing cloud misconfigurations, like an S3 bucket left open to the world, or exploiting workstations and endpoints to find valid credentials to the cloud, and from that to directly access this production environment. And as these attack vectors became more mature and common, security also adjusted with the methodologies, security systems, providing prevention and detection capabilities, and actual positions with the purpose of dealing with these threats, like DevSecOps, cloud security engineers, and AppSec engineers, for example. So as these attackers are having a hard time exploiting these vectors today directly against the cloud, they are aware of how popular CI/CD is, which is the tools and processes that ship code and infrastructure to the cloud. And recently, especially during the past 3 years, I would say, we see an evolving attack surface, abusing this software delivery process, taking advantage of the connectivity and processes involved in shipping application and infrastructure code to production. So if we head back to these infamous cloud incidents from before, with known examples from years like 2016 and 2019, today we see more and more attacks against the cloud. However, these ones originate from the software delivery process. Let's see some examples just from the last year. LastPass that had their dev environment hacked, leading to a big customer's data leak through cloud storage service. Dropbox with 130 GitHub repositories compromised in a successful phishing attack, and Toyota that had access key to their cloud disclosed in a public repository on GitHub. So hackers that are able to run malicious code inside an organization's CI, they are also able to do the same things that those CI/CD systems and environment can do, and that is get to production environments. So let's start seeing how attackers can abuse your pipelines to reach their goals, to reach production. So here's a basic CI/CD pipeline. We have a developer here with the right permissions, pushing code to a repo that is linked with a Jenkins pipeline that ships code and even infrastructure to production. In this case, AWS, just as an example. Again, this is the crown jewel where the attackers want to reach. And here comes the attacker. It can be easily identified, by the way, since it's red and it wears a hoodie. Now, the attacker wants to reach production, but it might be challenging for the reasons that we just mentioned, right? It's not so straightforward to succeed doing it today. So the attacker knows that there's probably a CI/CD pipeline which leads there, which leads production. Maybe if the attackers can hijack the developer's account, for example, they can take advantage of the pipeline to get there somehow. But hijacking one specific developer is challenging, right? This developer might be security-oriented, and they might not fall so easily to the old tricks of hackers. But lucky the attacker, this developer probably doesn't work alone. but it's part of a bigger team working together on this code project. Each of them has the required permissions on that repo, and now the attacker needs to hijack one of their accounts to move forward. But that still sounds a bit challenging, right? It's only 5 people. But thing is that even though this is the team working on this project, we know that maintaining permissions on the SCM is a huge mess. And probably not just this team has permissions on the repo, but many other people in the organization, right? What about product managers, program managers, QA, DevOps, just people in the organization that got permissions without any good justification. So the attacker doesn't really need to target one specific user, right? It can compromise any of these users that have access to the repo, which gives them the initial footprint in the CI/CD on their way to production. By the way, each of these users might have a username and password, or an access key, or a deploy key. There are many different authentication mechanisms belong to many different users that have permissions, and the attacker only needs to compromise one of them. So in this talk, we won't focus on how attackers can compromise these developers' account. That's a topic for another talk. The important thing is that it happens all the time. We keep seeing news about this topic all the time. And our focus today is on the possibilities of the attackers once they compromise a user account in the SCM, like this. So now, in this phase, the attacker gained wide permissions on the repository. They don't have direct access to the CI or to production. This is their initial foothold in the organization, in the software delivery process. So now what we'll do is to cover 4 attack vectors that the attacker can use to reach production through this foothold in the repository. Starting with the first attack vector, direct PPE or direct poisoned pipeline execution. Now, PPE has 3 different variants. This is the first one out of them. So we are in the same spot, right? We have the attacker here that gained permissions, write permissions to a repository linked with the Jenkins pipeline, shipping code and infrastructure to the crown jewel of the organization, to production, to the cloud environment in this case. Let's see what the attacker can do, because he doesn't have any access to the pipeline or to production, but only to the repository. So first thing that he can do is to have a look at the code. Maybe there's something interesting there that will lead him to the next phase. When he takes a look at the files there, he sees a file named Jenkins file. Now, Jenkins file, that's the name of the CI configuration file that defines pipelines, that defines for the pipeline exactly what commands it should execute when it is triggered. It sounds like an interesting path, right? Because maybe I can tell the pipeline what to do if I get to modify this file. Thing is that this repository was modified by its admins with branch protection rules. This is one of the most common ways to protect sensitive branches in a repository to prevent from users, in this case the attacker as well, to push unreviewed code to the repository. So if the attacker would try to directly push code and modify the Jenkins file into the main branch, this would fail in this case. But what about pull requests? Pull requests also trigger pipelines in many cases, and this is unreviewed code that we also want to build, test, and scan for security issues, right? This is why usually we trigger pipelines over pull requests, over PRs. It looks like an interesting opportunity, so the attacker steps into the Jenkins file code to see what's happening there. Let's see how it looks like. So this is how it looks like. This is like a standard Jenkins file, pretty basic. We see a few stages here. The first stage is named build in line number 4. We have another stage called test, and it's used to build and test our code, like I just mentioned. And inside the build stage, we see a step that loads AWS credentials stored in Jenkins that are loaded into memory as environment variables. And while they are loaded, some commands are executed, like make build and make clean in this example. What the attacker can do is to modify this Jenkins file with malicious commands that while the credentials are loaded into memory, this malicious command in red that you can see will take all the environment variables and send them to a remote server that is controlled by the attacker. So let's see how the whole attack flow looks like. What the attacker can do is to create a pull request with the malicious Jenkins file that I just showed you. What happens next with the creation of the pull request is that the Jenkins pipeline will automatically be triggered, fetching the code from the repository, from the pull request, including the malicious Jenkins file. And the malicious Jenkins file, and not the original one, will be the one that will define to the pipeline exactly what commands should run. So at that moment, the pipeline will run the attacker's malicious code. So now we have remote code executed in the pipeline, remote malicious code. As you remember, next phase is that credentials are loaded into memory and send these credentials to the attacker server that can now directly access the cloud environment. And that's direct poison pipeline execution, direct PPE, because the attacker poisons the pipeline by directly modifying the configuration file that defines the pipeline, defines what the pipeline should execute. And now you might think that, like, in order to execute a direct PPE attack, attackers need to obtain access to a developer's account. That's correct. And if the attacker gain access to a developer's account, there are many other attack vectors to execute, like moving laterally in the network, access production directly, etc. But I'd like to remind you the first slides in the talk. Like today, many efforts are being made to reduce the attack surface in the other vectors to increase prevention and detection capabilities. And along with that, there are poor capabilities in the CI/CD for visibility and prevention and detection of threats. So I would like to ask you, if a direct PPE attack is executed in your environment, would you have the ability to know about it? And the answer, in the majority of cases, is no. It's very hard today for organizations to protect against it and to prevent and detect it. Okay, so security and DevOps decided to protect against the modification of this CI configuration file when running unreviewed code, like in this case of the attacker. This was unreviewed code running in the pipeline. That's a problem. This can be done in different ways, like fetching the Jenkins file from the main branch or storing it in a separate repository. Let's say that now this file is protected, and that actually protects us against direct PPE. That's good. But does it mean that your environment is secure against PPE attacks in general? Well, of course not. Otherwise, I wouldn't be asking. So let's move on to the second variant of PPE, which is indirect poison pipeline execution, or in short, indirect PPE. Okay, so here we have a similar environment. We have the attacker here that obtained credentials to a repository linked with a pipeline, but in this case, the Jenkins file is protected. The attacker cannot simply push code or create a pull request that modifies this Jenkins file and create and execute a direct poison pipeline execution attack. So the attacker tries to think of other stuff that he can execute, other ways to reach the cloud in this case. So he takes a look at other files in the repository, and he sees an interesting file called makefile, which you probably know. Makefile is a configuration file that you can define some functions that will that you can later on execute in the shell. So I want to remind you that in the Jenkins file, we saw a reference to this makefile because in the build stage, after the AWS credentials were loaded into memory, two commands are ran. One is make build, and the other one is make clean, which are defined by makefile. If we look at the makefile, we can see here the definitions of the different make functions in use. What the attacker can do is to modify these commands, in this case of the build function, that will simply do what I just showed in direct PPE. It will take all the environment variables when make build is executed and send them to a remote server hosted by the attacker. So let's compile it all together. What's happening here is that the attacker creates a pull request, but now he doesn't modifies the Jenkins file with malicious code, but rather modifies the make file, as I just showed you, with malicious commands. With the creation of the pull request, the Jenkins pipeline is triggered, fetching the code with the original Jenkins file, which starts running its commands. It loads, it starts the build stage, and then it loads the AWS credentials. Then it runs the make build command. And make build command now refers to the modified malicious function that we just edited in the make file. So now malicious commands are executed in the pipeline, which sends the credentials of AWS to the attacker that can now directly access it. So rather than poisoning the pipeline by inserting malicious commands directly into the pipeline definition file, like in direct PPE, now in indirect PPE, an attacker injects malicious code into files which are referenced by the configuration files. That's indirect poison pipeline execution. Okay, moving on to the third and last variant of PPE, which is public PPE, or in short, 3PE attack. So here, the attack starts from a different position that we've just seen. The attacker didn't obtain write permissions on the repo. In this case, there is a public repository linked with a Jenkins pipeline. Public repositories, like in open source projects, for example, they allow any user to contribute, usually by creating pull request after you fork the repository, suggesting changes to the code. This project can be linked with a CI to automatically test the code, for example. Now, to execute a PPE attack, whether direct or indirect, the attacker forks the repository. Then the attacker can modify the Jenkins file to contain malicious commands, like the example we just presented, similar to the steps like in direct PPE. Now, if the pipeline of the public repository runs unreviewed code and it can run by an anonymous user, it is susceptible to 3PE, because now a pipeline will be triggered fetching the code from the fork itself that was used to create a pull request. Malicious commands will be executed in the pipeline, again, sending the credentials to the attacker that can now access the cloud. Now, this whole attack obviously depends on how secure the configuration of the CI is. I will say that today, at least modern CIs like GitHub Actions, Circle CI, all of these ones, they provide pretty good secure configurations by default, but they're always changed. So I would say that most organizations are usually protected against 3PE, but not all of them. And when you're not protected against public poison pipeline execution attack, this is lethal. This is a really bad situations that you don't want to be in, because it means that any anonymous attacker in the world can execute malicious code in your CI freely and access secrets like to production, for example. Okay, so poison pipeline execution, PPE, is a great way for someone with permissions of a developer against the SCM to escalate their privileges and move laterally to production environment. But let's have a look on how PPE is effective for attackers, for example, comparing to the more traditional Active Directory or cloud-based attack techniques to gain a strong foothold in the organization. Let's have a short comparison. So in terms of difficulty of exploitation, the traditional techniques sometimes require more advanced skills and technical expertise by the attacker, crafts that sometimes take even years to learn. And in PPE, you just need to create one pull request. It's pretty straightforward. In terms of likelihood of exploitability, how likely an environment is to be exploitable, traditional techniques are well known today with numerous protections in place. And in PPE, nearly any environment we get to see is susceptible to PPE. In terms of detection, likelihood of detection, so again, like traditional techniques have numerous detections, alerts, people hunting for them on a daily basis. And in PPE, if you're an attacker issuing a malicious pull request, you are pretty unlikely to get caught. And in terms of impact, they both have a really high impact on the organization. So the choice for what to do if you gain permissions or compromise the workstations of an engineer is pretty obvious now, right? And you can easily see why attackers choose more and more to go in the path of the engineering environments through CI/CD to reach production, and less in the more traditional ways to do that. So after we covered the three variants of PPE, let's move on to the fourth and last attack vector for today through CI/CD, which is bypassing required pull request reviews in GitHub. Okay, so here we have an environment where GitHub is the source control management system, the SCM, and there is a repo linked with Jenkins, similar to what we had before. Also, this environment is a bit different from the one we've just seen because the CI pipeline is only triggered when code is pushed to the main branch and not on creation of pull requests. Now, there are branch protection rules in place. So if the attacker will attempt to push malicious code to the main branch, whether malicious applications or infrastructure code, that would fail. So we can't execute PPE in this case, not direct and not indirect. So what the attacker can do. So the possibilities for the attacker are very limited. Users can't approve a pull request that they create, obviously, that would fail the entire security and quality mechanism of branch protection rules of required reviews. And the attackers can be naive and create a pull request with the hope that some other developer would approve their malicious PR. But of course, that if they would try to fool another developer to approve malicious code, I want to guess that this attempt would fail. So the attackers can only create pull requests with their malicious code that they can't merge to the main branch, or can they? This is where GitHub Actions steps in. But question is, why am I talking about GitHub's CI solution, which is not even in use in this organization? They use Jenkins, right? So there's something interesting about GitHub Actions or GitHub organizations that you should know. Any organization any GitHub organization has GitHub Actions installed and turned on by default. Now, any user with the right permissions on the repository can create a workflow file. This is how Actions pipelines are defined, similar to the Jenkins file. And these workflows will immediately be executed. Now, sounds like an interesting direction, even though GitHub Actions won't lead me to production in this environment, right? Because there are no secrets stored in GitHub Actions. It's not linked with the production environment, so it probably won't lead me to anywhere. But still, that sounds like an interesting path. I can execute CI pipeline, CI workflows in GitHub Actions as the attacker, even though it's not used in the organization. So what can the attacker do? The attacker can create the following workflow configuration file as part of the pull request. We can see here in the workflow file on line number 3 that the workflow is triggered by the creation of pull request. That's the workflow created by the attacker. Also, the developer can define if the workflow would run with read or write permissions against the repository that triggers this workflow, this pipeline. Now, it shouldn't be a big deal, right? Because the attacker already has write permissions on the repository. But another thing, interesting thing that you should know about GitHub Actions is that a workflow runs with the GitHub Actions bot user and not with the identity of the developer that triggered the workflow. This bot user also counts as a developer in the GitHub organization. At the bottom, you can see the code that runs in the workflow. That's a simple API request to GitHub directing to approve the pull request that was just created and that triggered this workflow. Might be a bit complicated. Let's compile it all together and see the attack flow. So the attacker creates a pull request with the malicious code that he wants to ship to production and a workflow configuration file of GitHub Actions, the one that I just showed, instructing to approve that pull request. Now, with the creation of the pull request, the workflow is automatically triggered. It has write permissions against the repo, so it successfully approves the PR using the GitHub Actions bot user, as you can see here. So now the attacker creates a pull request with the malicious code, with the malicious workflow, and automatically this workflow approves that pull request that triggered the workflow. Inception, right? So now the attacker is not blocked from merging the code into the main branch. It has the approval it needed, and the attacker can successfully merge it, now the code can be merged, and it finds itself in the main branch. And this merge triggers the actual pipeline, the Jenkins pipeline used in this environment, which is the Jenkins one. This is the sensitive pipeline that has high permissions to AWS, so the attacker can easily use it to steal credentials and to access the cloud environment like we've seen in the previous attack flows. Okay, pretty cool. So I reported this vulnerability to GitHub like, I don't know, 18 months ago through their bug bounty program. They acknowledged it and released a fix that allows you to restrict GitHub Actions from the reviews made by GitHub Actions to be counted towards approval. Now, you need to know that it's not set securely by default in existing organizations created after this feature was released, just in new ones. Sorry, it's not set securely in organizations created before the feature was released, only in new ones. So if your GitHub organizations were created more than, I don't know, 18 months ago, I recommend having a look at your organization settings. I would do it anyway, because it might have been changed in the last, I don't know, weeks or months. Okay, cool. Let's summarize what we covered here today. So we talked about the 3 variants of poison pipeline execution, PPE, a method used by attackers to run code in the CI without having access to the CI, and from there move laterally towards sensitive systems like production. We talked about direct PPE, where the attackers alter the CI configuration file directly. Indirect PPE, where we alter a file used by the CI configuration file. And public PPE, or 3PE, where PPE is exploited through public repositories. We also saw a way to bypass one of the most common mechanisms to secure sensitive branches, the branch protection rules, with the purpose of reaching production. So, to summarize, pipeline jobs are practically code execution as a service. This is how you see it as developers, as DevOps, but this is also how attackers see it, unfortunately. I would like to end this talk leaving you with one question to ask yourselves: how far can an attacker with your permissions go? So thank you very much, and I'm available for any questions you may have.
Thank you, Omer. Appreciate the great presentation. Loved all the Kill Bill references. Those were fun. Yeah, like Omer said, get your questions in now. Now we're going to take the time to answer any questions. If you do want to follow up with Omer or with Palo Alto, you can reach him on Twitter. You can reach out to Palo Alto's website. They've got all the information there. One question that did pop up is more of a technical or logistical question, is that will you receive the slides and the recording after the session's over? And the answer is yes. Everyone will be receiving this presentation and the recording after this is over. So you can refer back to it later at any time. I believe there also might have been an offer for a free trial pop up at some point during the webinar. If you didn't, be sure to check out the website. There'll be a free trial there. Maybe we can even put the link in the chat to make sure everyone got that. There's also at the very top right of your screen, there's a link you can click on to get the full the top 10 CIC security risks. There you go. There's the pop up for the trial. So be sure to check that out if you're interested. And then again, you can find out more information on the Palo Alto website. Other than that, I just want to say thank you so much to Omer for joining us. I really appreciate you walking us through all that. It's, again, really, really important information, vital to anybody who's using CI/CD practices, which probably is quite a few of us these days. So thanks again, Omer. Thank you, everyone who joined us. We had a really great turnout today, so thank you. Again, be sure to check out our website, dzone.com/events, for all of our other events. We've got plenty of on-demand webinars. This one will be on demand as soon as we're done with the session here. We've got, again, virtual roundtables, fireside chats, a whole bunch of other great events. So again, that's dzone.com/events. You can see everything we've got there. Thank you again to everyone for joining us. We really, really appreciate it. Thank you, Omer. Hope everyone has a wonderful rest of your week, and we will see everyone next time. Thanks, everyone.